few more notes about electrolytes. Electrolytes can be strong or weak. And the key is how much do they ionize. Remember, ions are the key to conducting a current. And hydrochloric acid actually does ionize very well. In fact, when you put it in water, 100% will be present in the ion form. And that's the key. It ionizes completely, therefore it's strong, a strong electrolyte. Notice this arrow. The way we write the arrow is important because since I wrote it just going forward only, that means that when you put this in water, it breaks apart and these stay apart. They don't go back together. Compare that to our weak electrolyte. A weak electrolyte ionizes only partially. So a common weak electrolyte is acetic acid. It ionizes only partially. So only a little bit is ionized. Most of it will be in the molecular form that doesn't have charges, so the ion concentration of this will be lower because not very much of it breaks apart. Notice the arrows that I have, they go both ways. That means that once it breaks apart, these two find each other sometimes and go back to being the molecular form. This is what we call a reversible reaction. And so it also gives you another way to tell if it's strong or weak. On the weak electrolytes, the arrows go both ways, and that is why only a little bit of it will be in the ion form. On the strong, the arrow only goes forward, and that means when it breaks apart, it stays apart. Okay. One last thing about this one. Acetic acid is one of our common compounds, and you find it in vinegar. It's one of the common compounds that in the lecture part of the class I'd like my students to know. So know that acetic acid comes from vinegar, and you might remember this ion. This is acetate. It has a related name. Next, let's look at some factors that affect how well something dissolves. The first is the nature of the solute and solvent. And what we mean by nature is the compound polar or nonpolar? And actually when we categorize these, we say polar and ionic kind of in one category and nonpolar in the other category. Polar and ionic compounds, even though this one's covalent and this one's ionic, they have charges on the particles, and that's the key. That they interact well with each other, they have attractions with each other, and that allows them to mix well. Water, certainly in this category, sugar and salt all fall under this category of ionic. Our nonpolar compounds are things like gasoline, oil. You should learn that carbon and hydrogen compounds, hydrocarbons, are nonpolar. So when we look at a chemical formula, if you see a lot of carbon and hydrogen only, then it's going to be a nonpolar compound and it probably won't dissolve well in water. If you start seeing elements in the organic compounds, we look for oxygen and nitrogen in particular, Those two make the compounds more polar, and so you'll tend to see those things, compounds with oxygen and nitrogen, are often in this category. Okay, so the type of solvent affects solubility. If it matches the solute, it will dissolve. Oh, by the way, you may remember that, or you may be wondering, because usually if you want to dissolve some oil, yeah, you could get out some gasoline or turpentine or something like that, but probably if you're trying to clean up oil, you'll use soap. And the way that soap works is that soap is such a big molecule that it has both a polar part and a non-polar part. It has like a polar end and then a big non-polar part. And so it kind of brings these two together. It has a part of the soap molecule interacts with water, part of the soap molecule interacts with the oil that you're trying to dissolve, and so it helps you out there getting them together. We'll be making soap later in lab. It's kind of a fun one. We make lye soap. Okay, another factor in getting to dissolve is temperature. If you increase the temperature, that normally increases solubility. And this is true for solid solutes in liquids. That's the most common type that we talk about in here, but it is different. It is a different trend for gases. So this is for solids when you're dissolving sugar in your tea or salt in your water. That's how it works and generally true. Okay, so those two were factors about what will affect how much will dissolve. There are some things that we can do to speed up the process, though. If something is going to dissolve, what do we do to speed it up? First thing is, of course, stirring. That increases the rate of dissolving because it makes a lot of solvent contact, and that's the key. The solvent literally pulls apart the solute by forming attractions with it and stuff. So a lot of contact is made that way. And then the other thing we can do is if we use smaller pieces of the solid solute as opposed to larger chunks, that will increase the rate that it dissolves, because with smaller pieces, so if I have like regular table salt versus if I'm trying to dissolve chunks of rock salt, the smaller pieces will dissolve faster because they have more surface area exposed. There's more that can be dissolving at one time. In a big chunk of salt, all the parts of the salt that are buried in the middle can't be dissolving. They're just waiting to be exposed.